friends, in this video we will study about the branch instructions in 8051 microcontroller. So let us start with our topic. The 8051 microcontroller, it is the most common and the first microcontroller, general purpose microcontroller which was developed by Intel. This 8051 microcontroller, it has various instructions which can perform different types of operations like addition, subtraction, logical operations. Also it can perform data transfer operations, also can be performed by these instructions. So all these instructions, they are categorized into different categories depending upon the type of operation performed by them. So in these categories, the one type of category we have is the branch instructions. Okay, these branch instructions, what they do, suppose we are writing, the main program is written in the memory, and in this main program, if some instructions are written which are changing the sequence of the program execution to some other memory location, means like in the same sequence the program is executed and suddenly we encounter an instruction due to which the main execution or the sequence is changed and it has to jump to some other memory location. So that type of instructions are called branch instructions. Okay. So in this video, we are going to study about the branch instructions available in the instruction set of 8051 microcontroller. In this branch instructions, we have the first instruction as the jump instruction. Now this jump instruction, it can be of three types. So jump instruction, it is of three types: relative jump, short absolute jump and long absolute jump. These three types are on the basis like how the, suppose the main program is written, so if the range of the jumping, means program changing, sequence change, it is in a short range, so it will be called the relative jump, means relative to some value if we are jumping, then it is called the relative jump. If we are the jump is a short jump, so it will be called short absolute jump. If the jump is long, then it is called the long absolute jump. So this is all depending upon that in which range we are jumping. Okay, the microcontroller has to jump to that memory location. Okay, first we will study the relative jump instruction. So relative jump instruction, it is a jump instruction which is going to replace the contents of the program counter with an address, and that address is relative to the address like program counter. It always holds the address where the next instruction is written. Okay, so suppose let's diagrammatically see what is this jump instruction. Suppose that jump instruction is written here. Now this because microcontroller, when it is executing this jump instruction, it has to jump to some memory location whose address is given here. Okay, now this address, next we will having the program counter. It is going to hold the address of the memory location where the next instruction is written. So this address what we can write here after this jump instruction, it can be in the range from this next instruction 128 bytes less than it or 127 bytes greater than it. Okay, so all the addresses which are less than this next instruction address by 128 or in this range or greater than this by 127, all this memory location can be used. So this is the range of the jump instruction. As this jumping of the program, it is relative to this next instruction memory address. That is why it is called the relative jump, because related to this next instruction, the jumping operation is being performed. So here I have written that jump that replaces the program counter content with a new address which is greater than or less than. So here I have written that jump that replaces the program counter content with a new address which is greater than the address following the jump by 127 or less. You can see here that this is the instruction which is following the jump instruction, that is next instruction, and greater than this by 127 or less than any value can be here. Maximum range is 127, less than range it can be 0, it can be 1. Okay, anywhere it can jump, and also it is less than the address following the jump by 128 or less. So for the instruction which is following the jump instruction will be the next instruction. So less than this next instruction we have 128 bytes or less than. So any memory location which is in this range, that can also be used. So total range we are getting is 128 and this is 127. So if we total it, because next instruction is also written here, so total range we are getting is 256. Okay, 128 for this, 1 byte is for this, and 127 is for this. So this is the relative, or we can say the program range which is given to us, that in this range the jumping operation can be done. The jump and this address which we are getting, it is the range of this address. So because it is relative to this next instruction, that is why it is called the relative jump. Now, what are the advantages of this relative jump? Now here, because the total range we are getting is of 256 bytes. So 256 bytes means we can address it from 00 to FF. Only 1 byte address we have to provide in the instruction. So 1 byte is for the jump instruction, 1 byte is for the address. So the total instruction bytes will become 2 byte instruction. Okay, so number of bytes occupied by that instruction, it will be reduced, and we have to provide this 1 byte address in the 2's complement form. So what we are getting here, we are writing the jump instruction. So ahead of it we can write, means the ahead range is from 0 to 127, and behind range we are having is -1 to -128. So this is the total 256 range we are getting. Before means after this jump instruction we can use this much memory locations for the jumping operation, and before this jump instruction we can use this much memory locations. Okay, total 256 is there, so it becomes only a 1 byte address we have to provide, and that also in the 2's complement form. So that is the advantage of relative jump, because this instruction is requiring only 2 bytes, 1 byte for the address and 1 byte for the opcode of jump instruction. Second is that now programs in which relative jump instruction is used, so in those programs they can be easily relocated because we know the range of the program jumping. Okay, so range we can know, so we can easily relocate the programs because they are on the same page. Okay, so that is the advantages. Now disadvantage is also this range, because the range of jumping is very less. It is only 256 bytes. The other memory location cannot be used for storing the program. Okay, so disadvantage of this becomes is short. Now what are the instruction which uses this relative jump? Let's see some examples here. This instruction S jump, it is using the relative jump. Here we have to provide the relative address, that how many bytes we have to jump, we have to skip, and at that memory location we have to jump. So this is a type of unconditional jump, because no condition is required here. Every time this instruction is executed, microcontroller has to jump at that memory location. So it is a type of unconditional jump. No condition is specified in it. The remaining jumps we are having are the conditional jumps. So these are all the conditional jumps where some condition has to be specified, then only the microcontroller will jump to the memory location. Here we have to provide the relative addresses. First instruction is jump on carry, means when the carry is equals to 1, then only it is going to jump at this relative address. Jump on no carry means when the carry flag is 0, then it is going to jump. Jump if bit is 1, means if the bit is equals to 1, then it is going to jump. Jump on no bit means when the bit is equals to 0, then only it is going to jump. This bit is specified in the instruction itself. Jump on bit and when bit is equals to 1, and then clear the bit, means when bit is equal to 1, then it is going to jump and then clear the bit. C is to clear the bit. CJNE means compare the 2 bytes, the destination byte and the source byte, and if these 2 bytes are not equal, then only you have to jump at the relative address. So the 2 bytes which have to be compared, they are given in the instruction itself. So when the condition is satisfied that the 2 bytes are not equal, then only it is going to jump at the relative address. Then D, J, N, Z means decrement and jump when it is not equals to 0. So the byte is given to us, we have to decrement this byte, and if this byte is not equal to 0, then it is going to jump at the relative address. Jump on 0 and jump on no 0, it is according to the result. If the result of any operation it is coming out to be 0, then it is going to jump, and if it is not coming out to be 0, then it is going to jump at the relative addresses. So in these instructions, if the condition is specified, then only jumping is done, whereas in the S jump, it is always going to jump to the memory location of the relative address. So it is unconditional jump and it is the conditional jump, and these are using the relative addresses, that is range will be from -1 to -128 and ahead range will be from 0 to 127. So total 256 bytes range is available. Now next type of jump we are having is the short absolute jump. Just like in relative jump, we are calculating the program range, the address range, that in this range the jumping can be done. So in short absolute jump, the address is calculated as follows. Like in 8051, we have the total program memory as 64 kilobytes. Now this 64 kilobytes memory, it is arranged in the form of 32 pages, and each page is acquiring 2 kilobytes of memory. Okay, each page is of 2 kilobytes. So total we are getting 64 kilobytes. Now if we talk about their addresses, so how the addresses are defined, because 64 kilobytes are there, so 16-bit address will be there. Okay, now in this, because we are having 32 pages, so first 5 bits we are having other page number, and remaining 11 bits they indicate the addresses. So first we will have the page number, and then we will have the address. So page numbers are like 00, 01, 02, 03 till we are getting 1E, 1F. The total page number is of 2 kilobytes. Okay, each page is of 2 kilobytes. So suppose 00 page number is there. So 0000 till we are getting 07FF. Okay, next page we are having 01. So it will start from 0800 till 0FFF. So total 2 kilobytes of memory is there on each page, and this total pages we are having is 64 kilobytes. Each page is of 2 kilobyte, and total 32 pages are there. Now here if you see the addresses, the first bit if you see, it is 0. If we expand this, what we are getting, this is all the bits are 0. In this case 0000, then we are having 7, then F, and then F. So if we see the starting 5 bits 0000 and 0, so starting 5 bits are constant. In this range, the starting 5 bits will be constantly 0, so the page number is 00. Next page if you see 0 and 8, so starting 5 bits will be 0, 0, 0, 0 and 1. So here we are having the page number 01. In this way all the range is decided. Next range we are having is 100, 17FF. Here if you will see, all the bits will be, it is 1 means 0001. It will be 00010. So page number is 02. Okay. Next range if you calculate, it will be 00011. So page number is 03. So in this way, if you see all the bits, the starting 5 bits they denote the page number, and the last 11 bits they denote the addresses, and each page is having 2 kilobytes of memory. So in absolute jump, whenever we are talking about the absolute jump, it means we are jumping on the same page, that is 2 kilobytes of page. So we will require only the 11 bits. The total 16 bits are not required because page remains the same when we are jumping. So in the program counter where the address is stored, so in the program counter we will take the 5 bits of the program counter and 11 bits will be specified in the instruction itself. Let's take an example so it will be clear to you. The instructions which use the absolute short absolute jump are A call and A jump. Here we have to specify the addresses which are of 11 bit. So 11 bits of the addresses in this 16 bits, 11 bits we are getting from the instruction itself, and remaining 5 bits we are getting from the 5 bits are the upper 5 bits of program counter. Okay, so what this instruction byte, it will become 1 byte is for this opcode A call and 1 byte is for this address 11-bit address. So total 2 bytes are there. So this short jump instruction, they become the 2 byte instructions. Okay, so this was short absolute jump. Third type of jump instruction we have is long absolute jump. Now the total program memory we are having is of 64 kilobytes, and 64 kilobytes addresses ranges 0000 to FFFF. So in this case, we can use this entire range of the program memory for the jumping operation. So total 64 kilobytes is available to us. So that is why it is called the long jump, because large memory sizes available to us. Now here, if we see the address instructions which use this long jump are L call, L jump, where we have to specify the 16-bit address. Okay, so in these three instructions, the long jump is available, means long jump is used. Long call instruction, 16-bit address, this 0000 and 2FFFF, that will be the 16-bit address. And L jump, also we have to specify 16-bit. 1 bit is for this, 1 byte is for this opcode, and 2 bytes for this 16-bit address. So it will become a 3-byte instruction. Okay, and jump indirect addressing is used, means the contents of the accumulator plus the data pointer. So 8 bits of the accumulator and 8 bits from the data pointer, together it will form the 16-bit address. So here also long jump is used. So these are the 3 types of jump instructions: relative jump, short jump and long jump. Now the jump instruction, there is another classification of the jump instruction. One is unconditional jump and second is conditional jump. Means the jump instruction, they can be classified in two ways. First way, what we studied is based on the program range, that how much range is available. So on the basis of that, there are three types: relative, short and long. And on the basis of the condition, that whether the jumping is based on some condition or not, we have two types: unconditional and conditional. In conditional jump, no condition is specified in the instruction. Every time when the microcontroller is executing an unconditional jump instruction, it is going to jump at that memory location. Now, unconditional jump instruction, they also involve long jump and absolute jump and short jump. And in conditional jump, the condition will be specified. So first study the unconditional jump instructions. So first long jump instruction is there. So for this we have the mnemonic L jump, which is a 3-byte instruction. Here we will specify the 16-bit addresses. Okay, and this instruction, it is a 3-byte instruction, what we studied earlier. Next we are having the A jump, in which we specify the 11-bit address. Okay, and short jump instructions, which is a 2-byte instruction, in which the address range is from, in the forward direction we are having, like we are writing the jump instruction, so in forward direction it can jump to 0 to 127 bytes, and in the back direction it can jump from -1 to -128 bytes. Just like what we studied, the relative jump, short jump and the long jump. So here also all the three types, they come under the category of unconditional jump also, because no condition is specified in it. So the unconditional jumps, they can be long jump, absolute jump or the short jump. Okay, and in these jumps the range of the jumping operation, that is different. Now let's come to the conditional jumps. In the conditional jumps, the program execution will change the sequence only when that condition is specified. That means that condition is fulfilled. In conditional jumps, we have different type of jump instructions, like jump on carry, jump on no carry, jump if bit is equals to 1, jump if bit is not equals to 0. So let's see that what are these jump instructions. So these are the conditional jump instructions, in which some condition is given, and when then condition is fulfilled, then only jumping is done. So first we have JBC, that is jump if the bit is equal to 1 and then clear the bit. So here we will specify the bit in the instruction, and when that bit is equals to 1, then only it is going to jump at some memory location, and after the jump operation it is going to clear the bit, that is bit will become 0. Then next is jump on no bit, that is when jump if the bit is equals to 0. Then jump on bit, that is jump if bit is equal to 1. So when the bit is 1, then we will use JB instruction, and when bit is 0, then we are going to use this JNB instruction. Okay, so to check these conditions, we will use the jump instructions which are related to the bit operation. Then these two are for the carry. Jump if carry is 0, and jump if carry is equals to 1. So this is associated with the carry flag. So when carry flag is reset, its value is 0. Then we have this JNC, and JC is when the carry flag is set. Now these two are for the compare instructions. Here it is going to compare the two bytes which are given in the instruction itself. One is the destination byte and second is the source byte. So register, contents of the register and this immediate data, they are compared, and when they are not equal, then it is going to jump at the memory location which is also specified in the instruction itself. Here it is going to compare the contents of the accumulator and this byte. The byte 8 bits, 1 byte is also given in the instruction itself. So this byte and accumulator contents, they are compared, and if they are not equal, then it is going to jump. So C is to compare jump at not equal. So jump if register is not equal to the immediate data. Here it is going to jump if accumulator is not equal to the byte. Okay. Then we have D, J, and Z, means decrement and jump if it is not equals to 0. What is the operand in this case? Accumulator. So it is going to first decrement and then jump if accumulator is not equals to 0. Here J and Z, that is jump if accumulator is not equals to 0. Here DJ, NZ and JNZ, what's the difference here? We have to decrement the accumulator and we have to jump if the accumulator is not equals to 0. Here no decrement operation is performed, only it is going to jump if the accumulator is not equals to 0. JZ means jump if accumulator is equals to 0. So in all these jump instructions, some condition is involved, and when that condition is fulfilled, then only the jumping of the instruction is done. Okay. So these are all the conditional jumps. Now all these conditional jumps, they are a type of short jumps. Means the range in which the program execution can change, that is 256 bytes. Means ahead of the jump instruction we can use 127 bytes, and back to it we can use 128 bytes. So total 256 bytes we can use. So all the conditional jumps are a type of short jump instructions. Now all these jump instructions, they are at the bit level also and byte level also. So here we will discuss now the bit level jump instructions. Bit level jump instruction means those instructions, those jump instructions in which bit level comparison is done. Means one bit is compared with another bit. Okay. Now all these bit level jump instructions, they are relative jumps. Means the address involved is the relative address. Okay. Now here if the conditions, it is going to check some conditions, and when those conditions are fulfilled, then it is going to jump at the relative address which is specified in the instruction. So we can say that the bit level jump instructions, they are a type of conditional jump instructions. Example of these instructions are, these are the 3-bit level jump instruction. We have studied earlier also these instructions, because here the comparisons or the conditions, they are specified on a bit, on a single bit. That is why they are called bit level jump instruction. First is jump on bit. That is when the jump, if bit is equal to 1, and where it is going to jump, the relative address which is specified in the instruction. So when the bit is equals to 1, then only the jumping is done. JNB, jump if bit is not equals to, sorry, bit is equals to 0. No bit is there means bit is equals to 0. So it is going to jump at the relative address which is given in the instruction. Next we have JBC, that is jump if bit is equal to 1 and then clear the bit. So earlier the bit is 1 and after the jumping the bit is cleared, means it is equal to 0. So these are all the branch instructions available in the 8051 microcontroller. We started with the jump instructions, that how the jump instructions are classified, like relative jump, short jump and long jump. After that we studied the second classification, unconditional and conditional. And in the last we studied the bit level jump instructions. So this was all about the branch or the jump instructions in the 8051 microcontroller. So I hope that this topic is clear to you. Thank you.